Okay, guys, I'm going to go through some ACT questions and some examples. Sorry, I am not there today. So this one, so we want to know which of the following number line graphs shows the solution set for this inequality. So the absolute value of x is less than -1. Well, the definition of absolute value tells us that we are going to get a positive number out of this, right? Well, if we get any positive number, so let's just say we get like a 1. Well, is 1 less than -1? And will this be true for any of them? The answer is no, this is not true, right? So since this is not true, that means that this is the empty set. Okay. This one, so as part of a probability experiment, Elliot is to answer 4 multiple choice questions. So we have 1, 2, 3, and 4. For each of the questions, there are 3 possibilities. So we'd say like we have A, B, and C for each of these. Okay. So, and only one of them is correct. If Elliot randomly and independently answers each of the questions, what is the probability he will answer 4 questions correct? Well, he has a 1 out of 3 chance of getting that one correct. He has a 1 out of 3 chance of getting this one correct. Same thing here and same thing here. Because there's only 3. So, like, if he chose A, there's a 1/3 chance that that's the correct answer. If he chose B, C, B. Okay. So, to find the probability, we're going to multiply all these together. Which 1/3 times 1/3 is 1/9. Times 1/3 is 1/27th, times 1/3 is 1/81st. So he has a 1 out of 81 chance of guessing those correct. Okay. This one, so the sides of an acute triangle, acute means that there is no, acute means that all the angles are less than 90. Okay, which measure 14, 18, and 20. And we want to know which of the following equations, when solved for theta, gives the measure of the smallest angle on the triangle. Well, the smallest angle is always opposite of the smallest side. So here's our smallest side. Opposite of that, this would be our smallest angle there. Okay, and they're giving us some equations here. So they give us these equations with sign in them, and they give us the equations with a cosine in there. And they say that A, B, and C are the sides, and capital A, B, and C are the angles. Okay, so this is called the law of sines, and we are going to learn it in more detail in like February. And this is the law of cosines. So the law of sines, see how we have all these angles in here that we need? Well, we need at least one angle, and we don't have any angles here, so we're not going to use the law of sines. Law of cosines, it's set up for us to solve for C. So I'm going to call this side, or this angle, C, which means the opposite is going to be little c. And then these ones I don't really care about, so this will be A, and this will be B. And this doesn't have to be C. It could be A if we wanted it to. But we would just have to replace all the A's with C's down here. So then this equation would have become A squared equals C squared plus B squared minus 2BC cosine of A. Again, we'll get into that like more in the future. Okay. But we're not going to do that for this one. So here... we can set up this equation now. So C squared, that's going to be 14 squared, which looking at this, I can already cancel those out. It must be J, but let's continue. So equals A squared, which is 20, B squared, which is 18, minus 2 times A times B times the cosine of C, which is theta, which is the same thing as J. They just like flipped these, which is totally fine. Okay. Okay. So let's find all the possible rational zeros here. So this is the P over Q stuff, where P is going to be the factors of the constant, and Q is going to be factors of the leading coefficient. Where in this case, the constant is 8 and the leading coefficient is 9. So factors of 8 are going to be 1 and 8, 2 and 4. Factors of 9 are going to be 1 and 9, and then 3. And then to do this, so to write these all out, let's start with the 1. So I'm going to take 1 and I'm going to divide it by 1. I'm going to divide it by 3, and I'm going to divide it by 9. So I have 1, 1/3, and 1/9. I'm going to do the same exact thing with the 2. So I get 2, 2/3, and 2/9. Do the same thing with the 4. Get 4, 4/3, and 4/9. Same thing with the 8. Get 8, 8/3, and 8/9. So then these are all the possible zeros. Yes, you have to put the plus or minus. Not technically a 1. And another thing, so say that in this list, you ended up getting like 2/6. Well, 2/6 reduces to 1/3, which we already would have up here. So you wouldn't have to write that one. Okay, if you have a fraction that repeats when you reduce it, then you only have to write it once. Okay. And let's do this one. So we're given this polynomial function and we want to find the zeros of it. So first, check if it factors. This one does not factor. So then we have to do the P over Q, which that's going to be factors of 8. So we have 1, 2, 4, and 8. Over factors of 6, which is 1, 2, 3, and 6. So our possible factors are going to be 1, 1/2, 1/3, 1/6. When 2 divided by 1 is 2, but 2 divided by 2 is 1, so I'm not going to write that one again. 2 divided by 3 is 2/3, and then 2 divided by 6 is the same thing as 1/3. Then I have 4. 4 divided by 2 is 2, which we already have. 4 divided by 3 is 4/3. And 4 divided by 6 reduces to be 2/3. And then the last one, I have 8 divided by 1, which is 8. 8 divided by 2, which is 4. 8 divided by 3, which is 8/3. And then 8 divided by 6, which reduces to be 4/3. So see, there's some that can repeat, and so we're just not going to deal with the repeating ones. And then when I do this, always check your whole numbers first. Okay, it's easier to deal with whole numbers than to deal with fractions. So if I plug in 1, so I'm going to have f of 1 equals, I'm going to use my calculator here. So 6 times 1, maybe, come on. So 6 times 1 cubed minus 25 times 1 squared plus 2 times 1 plus 8. I get -9, which is not going to work. So if I plug in -1, 6 times -1 cubed minus 25 times -1 plus 2 times -1 plus 8 equals 25. And I'm plugging these numbers into this function up here. Okay. Let's test 2. So if I do 2, 6 times 2 cubed minus 25 times 2 squared. Oh, wait a second. I might have done this one wrong. Oh, sorry, guys. Oh, this is actually negative 25. Didn't make that much of a difference. But 6 times 2 cubed minus 25 times 2 squared plus 2 times 2 plus 8 is negative 64. This is honestly like the longest part of these problems. So 6 times negative 2 cubed minus 25 times negative 2 squared plus 2 times negative 2 plus 8 is negative 144. Let's test 4. I think one of the 4s works. So 6 times 4 cubed minus 25 times 4 squared. I hope you guys are just doing this problem with me. It is one of your homework problems. Plus 2 times 4 plus 8 is 0. Halla freaking Luya. Okay, so that means that x equals 4 is one of the zeros. Okay, and I don't remember if I want you to put an x equals there, but it would be x equals 4. But I don't think it does. But, so we're going to do synthetic division with the 4. We have 6, negative 25, 2, and 8. So I'm going to drop down the 6. I get 6. 6 times 4 is 24. Negative 25 plus 24 is negative 1. Negative 1 times 4 is negative 4. 2 minus 4 is negative 2. Negative 2 times 4 is negative 8. And we're left with 0. So this is going to be 6x squared minus x minus 2. Then I'm just going to factor this. So 6 times 2 is negative 12. And then that's going to be negative 1. So I want to see what multiplies to be negative 12, adds to be negative 1. Well, that's negative 4 and positive 3. So then I'm going to have 6x squared. And I'm going to replace, that was so ugly. I'm going to replace those with that. So that'll be negative 4x plus 3x minus 2. Group these first two, group the second two. So between those first two, I can take out a 2x, and I'm left with 3x minus 2. Between these ones, I can't take out anything, so I'm just going to take out a 1, and I'm left with 3x minus 2. So the factors are 3x minus 2 and 2x plus 1. You can set those both equal to 0. For this one, we'd get 3x equals 2, so x equals 2/3. So that's another one of our zeros. For this one, I'm going to have 2x plus 1 equals 0, so 2x equals negative 1, so x equals negative 1/2. Now, this right here, are part of our f of x. We are just missing this one. So to put that back into its factor, if we have x equals 4, I'm just going to subtract it so I'd get x minus 4. So our other factor would be x minus 4. So the f of x equals will be x minus 4, 3x minus 2, and 2x plus 1. Okay? Have a good day at school. I miss you guys.